Sixth. Welcome everyone to our sixth Hack Sprint workshop, React Navigation with Data. So as always, we have the link to the slides and link to the README. A couple seconds to copy that down. And then our membership portal attendance code, very clever this time, courtesies of Eugene, and also feedback form link.
Okay, hello everyone again. This is just a small update if you were involved in groups for Hackspring. So goals for this week, hopefully you've already met with your group and designed a little bit about what your app is going to do and the features it's going to have. So for this week, hopefully you'll start splitting up tasks between what you've already decided to do overall, and hopefully you finalize your design as well. You should also probably set up GitHub so that you can share code. If you're not familiar with GitHub, it's just this nice code management tool, especially when you're in different places. And finally, if you still have time, you can start implementing your first feature. Next slide, please. So if you need any help with GitHub, helping flesh out your design, or just helping with any bugs you may be having, work sessions are the best place for you to get hands-on help with us. Again, they're every Thursday from 6 to 7 PST on the Hacksprint Discord, so come and stop by.
Reminder as usual, we'll be coding during this workshop, but we don't expect you to copy the code as we are showing it. We really want to emphasize just understanding things conceptually, understanding what the code does, and not frantically trying to copy down what we're typing. So today we're going to build a to-do list app, this is a classic React exercise. But the tricky part about this app is that there's going to be 3 screens. There is the list screen, which shows a list of all the to-dos. The create new item screen, which will allow you to create new list items, and then also a list details screen, which will, when you click into one of the items, it'll show you the details of the to-do list item. And the workshop title is React Navigation with Data. So we're going to be talking about how to share data between the screens. But before we get started with any coding, I want to talk about some JavaScript features, specifically some syntactic sugar. So what does that mean? So syntactic sugar means ways to write code that is shorter or more clear. So in JavaScript, you'll find pretty often there's multiple ways of writing the same thing. And this is because there's always new features, and programmers just like writing shorter code. So the shorthands that we're going to learn today are pretty common in React. And just to explain what syntactic sugar means a little more, we're going to go over an example. So this is something that we've already seen before. It's an arrow function. It's just the add function, takes in 2 parameters, x and y, and then returns x plus y. But the syntactic sugar way of writing this is that we can just get rid of the curly braces and the return, and then this means the same thing, but it's actually just shorter. So yes, just get rid of these unnecessary characters that we did not actually need. And then we can rewrite it this way, which means the exact same thing except shorter. Okay, so the next feature that I'm going to talk about is called object destructuring. So if we have an object, we usually want to use the values inside of the object. And commonly, we access those values using dot notation, save them to variables. So for example, there's the number property, and we want to save it into the variable called number. So we do const number equals episode dot number. But the shorter way to write this is called object destructuring, which is you just put these curly braces, you put the variables that you want, and then you put the object on the other side. So yeah, so these two ways of writing the code are the same thing. They both extract values from the object and save them into variables. But on the right side is shorter. So we like that one better. And a way that we're going to see this a lot today is through props. So this is an example component that has called episode, and it has two props, title and number. So this is the way that we've been writing it so far, where we have this props argument, and then we access the props saying props.title and props.number. But if we apply object destructuring to it, we, instead of props.title, we can just use title if we save it into a variable. So this is this can be useful, especially if you have title in a lot of places inside your component. If you, or you could have just props.title everywhere, but just to be a little bit shorter, you just put title. And the even shorter way to write this is instead of having the props named variable, you just write inside of the argument list, use object destructuring right there. And the other reason this notation is pretty nice is that when you look at it, just at the arguments, you know what props the component is expecting. So before, when we just had props here, the user, or if you look at like old code or code that someone else wrote, it might be hard to figure out what props that the component is expecting. But if you write it in this way, then you can immediately know, oh, this prop wants a title and it wants a number. All right, next we have the array spread operator, which is ... and it's just an easy way to copy items from arrays into other arrays. So usually maybe you would use a for loop to go through an array to copy it into another array, but the real quick way to do this is with the array spread operator. So here's an example. You just put ... and then the name of the array that you want to copy. So in this case, you have the array containing 1, 2, and 3. So we put the ... we just make a copy 1, 2, 3. You can put the ... array or and then comma and then add a few more items, or add an item and then copy the array. You can copy more than one array. Very speedy, very short. And next, like, I don't know why all of these have very fancy sounding names. This one is called optional chaining. And this is to solve the problem where if you have an object that's undefined, and you try to access a property on it, then you'll get an error. So for example, we have this variable episode, and episode, if we try to access episode.title, it'll give you a undefined, or it'll say that episode is undefined so that you get this error. If you didn't want this error, you would have to add a check. So for example, you can use a if statement to check if episode is defined or not. If it is defined, then return episode.title, otherwise return undefined. And the short way to write this is with this question mark dot. So instead of using this check, if episode, return episode.title, else return undefined, you just return episode question mark dot title, return episode title. And in this case, it's not that much shorter, but it does get much shorter as you have nested properties. Because if a property inside an object does not exist, then it'll be undefined. So for example, here I have a defined episode, but if I try to access a property that doesn't exist on it, I will get undefined, which is okay. There's no errors so far. Does JS not use null? There is null, but I actually don't really know the difference, but sometimes you get null and sometimes you get undefined. In this case, it's all undefined. FMenter has a more explanation of what the difference is. You can add that. But it's like in my opinion, it's like a weird JavaScript thing. Yeah. Yeah, so if you have something undefined, no errors, it's fine. But if you try to access a property, a nested property of that undefined property, then you'll get an error. But if we don't want an error, we can use a check again. It could be an if statement check, if check that episode exists, and then also check that episode.title exists. And you can imagine if there's even more nested properties, you just keep adding this to your if statement. It gets kind of long, but the real neat way of writing this is with optional chaining. You just do return episode ? Title ? Name. Yeah, so the rule is if nothing in the chain is undefined, the value is returned as normal. But if anything in the chain is undefined, then undefined is returned. So that was a lot. If anyone has any questions, please drop it in the chat. Otherwise, we have a poll to review all this. So I'm going to launch the poll. While the poll. Okay, also from before, the difference between null and undefined. Null is a value that means null, and undefined means you haven't assigned a value to it yet. Null is something that programmers usually explicitly set versus undefined, where it's like an automatic value. Okay. So let's review the poll. The first one, everyone got it correct. That's how you use object destructuring. The second one, 83% correct. It is an object that contains the properties title and details. So the way that you would write it, if it's two objects, it would be title in curly braces, comma, in other curly braces, details. Very tricky. But yeah, so that's how, so 10 people got that one right. And then the next question, yes, everyone got that right. Array spread, first one. And then, yeah, so number 4 is actually super tricky, and it is D, obj.c ? D is undefined. Yeah, I guess to explain this, I think it will help to show this on Google Chrome. Let me just do this in the console. Oops. Clear. Oh, so annoying. Okay. Okay, so I'm going to copy over this stuff. I can't copy from polls. Okay, hopefully I just memorized it. Const obj. Oh, okay. I did this before already. Yeah, this was very tricky. What was the other one? Undefined object. Okay, so we have that set up. So the first one is, okay, yeah, everyone got that right. Dot C dot B dot C. So yes, that is not undefined, that is 2, because everything just works out. You go inside object, B, and then C. The second one, obj.c. If I hit enter, there's no error. So it's just undefined. When you try to access C, it's just undefined because there is no C inside of obj. Okay, so that one was incorrect. And then we have Okay, yeah, this one is hard too. Undefined obj dot c dot d. Yeah, so if I hit enter, then there's an error. It's not equal to undefined. The reason is because undefined obj does not have a question mark on it. So if we had a question mark, then it'll be undefined. Here. But since there's no question mark, then there's an error. And then lastly, obj dot c dot d is undefined, and that's because obj is defined, so this is fine, and then c is not defined, but we have a question mark, so it's okay, and then you just end it with undefined. Yes, the last one was hard, but good effort, friends. Okay. All right, let us continue. So now we're gonna actually get started building the to-do list app. First, I'm just gonna talk through what the screens look like to get a better idea. So we have the list screen again. This will have a list of to-dos. You can cross them out. You can hit the little arrow to get into the list item screen. So if you click like the practice serve item, then you get some details about the to-do list item. And then we also have the new item screen, which you can input title and details, and that'll create a new to-do. All right, so I have it set up here already. I've pre-built all of the screens, but we can just talk about what goes into them. It's all stuff from previous workshops. So here I have the list screen. It is a flat list of list items. So list item is a component that I've created here that takes in the title and the done prop to determine what it looks like, as well as the toggle done. So when I click on it, it will change to be crossed out or not. And then we can see here that this item that is part of each flat list is this object. So we have this to-dos state where by default, I've initialized it to be this array, but later on, we're going to add some more things into this array, or the user can add more things into the array. But for now, I just have these two. And it will have the title property, the done property, and the details property for each to-do. And that is fed into this render item function, where we take the item and then we pass in the title into the list item title, the done to the list item done, and then the toggle done is the trickiest part. So what this does is that it makes, or we see the array spread, it makes a copy of the to-dos, and then it changes from done to not done, or the opposite, and then it sets to-dos using the state function, the function provided by use state. So that's the list screen. And then the other screens are a bit easier. So list item, all it does is it has 3 text components. And then for now, I've just hard coded some data in there. So it looks like something, but it doesn't, it's just hard coded. So it won't change. And lastly, the new item screen is just, it's mostly just 2 text inputs and then some labels. So pretty simple there. Okay, so first I'm gonna review how to add navigation. So I've already pre-installed React Navigation, which is the library that we use for navigating or changing between screens. So I can import the navigation container and then the create stack navigator function. I'll also notice that these like curly braces here is using the object destructuring syntax that we learned earlier today. So I'm going to use the navigation container to add navigation to the app. And inside the navigation container, I need to put a stack navigator. So I'm going to create a variable for that. And then inside the navigation container, I need to put my stack navigator. So to review, a stack navigator means that the screens will be one on top of another. And I need to list what screens there will be inside. So stack.screen. Component. So I'm going to have my to-do list screen, my list item screen, and then the new item screen. So I need to change their names. They should be unique names, and then also need to change what component it is. So I just imported the screens from their respective files. So if I save, nothing really happens because you can only see one screen at a time, but we do have this heading that tells you what screen you're on now. Okay, first I'm going to add some navigation between the to-do list screen and the new item screen. So I have this button for a new item, but it doesn't do anything right now. When I press on it, though, I want to go to the new item screen. So I'm going to take out the navigation prop. This is provided to you by React Navigation. And then when I press on the button, I'm going to go to the new item screen. Let's try that out. And it did work. And by default, it also provides you a back button. Nice. Okay, next we have the, when I click on these arrow things, I want to go into the list item screen. So this is, the arrow will be found inside the list item component. I use this vector icon from Ant Design. I just imported that. So it's right here. So I also need an onPress. So I actually can't do navigation.navigate here because navigation is a prop of list screen. So I'm going to pass in a function instead that will use the navigation prop. I'm going to call this function go to details. And then whenever I press, I'll just, this function will be run. So add this prop on the other side when I create each list item. So I can use navigation here because it's a prop of list screen, navigation.navigate. Go to the list item screen. Okay, let's try it out. Okay, yeah, so now when I click on the arrow, it takes me to the list item screen. But notice if I click either one, it just says the data is practice served, not done yet, all of this. So it doesn't change when I click on the learn how to spike item. And it also doesn't change if I cross out or uncross out practice serve. So right now it says not done yet. If I cross it out, it still says not done yet. So we need to be able to tell the list item screen what data to render. So let us talk a little more about that. How do we pass parameters between screens? So how does the list item know which item it is a screen for? Because different screens will need different data. So far, we use the navigation.navigate function in order to change screens. And the way to pass information between is we can just pass a object as the second parameter of navigate. So for example, I can pass the title or a object containing title, done, and details. And then it'll have the data that's necessary. And then on the other side, on the list item screen, we can use the route prop. This is provided to you from React Navigation as well. And then inside of the route prop, there's another property called params. And then inside of params is the same items that, or the same properties that we passed on the other side inside the list screen. And then once we have these, once we have title, done, and details, then I can use those variables inside my screen. So let's do that now. So here in list item, instead of having nothing as a second parameter, I'm going to put item. Recall that item, which is up here. It's one of these, so it'll look something like title, practice serve, done, true, and then details. So it'll look something like that. So that's what item is, and it's different for each item, each list item. Okay, so now I passed it from the list screen, and on the other side, we have to catch it. Okay, so here I can use the route prop, which is provided by React Navigation. I'm going to save the title, done, and details from route.params. And so params is a property that on route, this is part of the React Navigation library. And now I'm going to replace this hard-coded data with these variables. So, okay. Should be details. And so, wait, let's go back. So we actually can't use done here because it's just true or false. So I'm going to use this operator. We talked a little bit about this time, but basically it just means like if done is true, then return the first thing, which I'm going to put is the string done. And then if done is false, then return this other thing that says not done yet, or this other string. Okay, let's try this. Okay, so now if I click this, it says done. If I uncheck it, then it'll say not done yet. So the appropriate data is changed. And then if I click here, it does say learn how to spike with the learn how to spike details. Okay, neat. Does anyone have any questions? Cool. So while this works, this previous demo is actually anti-pattern. It's not recommended. And the reason is because this duplicates the data. So we have the data in one place in the to-dos array, which is part of the state of the list screen. But if we pass it over to the other screen, this duplicates the data. And for more complicated apps, this will cause like inconsistency, just passing the data around. So the better way to do this is to pass an ID instead of the entire item. But that does bring us to the question, like, how can the list item screen then know what the title and the details are just from the ID? And we'll find out next time on Hack Sprint. So we're going to take a break, but we'll go over it after the break. And also, while the break is happening, I have another poll. Cliffhanger, yes. Let's come back at Is 6:50 a good time? Let's do a 10-minute break. Okay, we're going to start off with the poll. I'll end it and share results. So the first question, how do you pass data between screens? The second answer is correct, navigation.navigate. The name of the screen, then comma, the data. The first answer is data as a prop. So it's not between screens though. It's like from the parent where the screen is. Actually, I'm not really sure how this would work. Yeah, the first one is not correct. For number 2, how do you access data passed in from another screen? It is the first one, const data equals props.route.params. So the data is inside of the route prop, which is inside of, and then inside of route is params. The second one is not correct, it's missing route. And then the last one, why would you prefer passing in the ID of the to-do instead of the entire to-do object? First answer is correct. You avoid having data duplicated in multiple places, which might lead to inconsistent data. Cool.
Great.
Good work, everyone.
Cool. Thanks, Christy. Cool. Let's hop into the second half. Apologies for you guys waiting on that cliffhanger. I know you were on the edges of your seat trying to figure out the next step. So with that being said, let us hop into it. Actually, before that, let's go into some recap so that I can teach you guys some concepts that you may have learned last week, but you need some refreshing on. So recall from last time, we went over what asynchronous programming was. So what asynchronous is that you are able to run different tasks at the same time. And the way that it accomplishes this is by starting one task, then jumping over to another task to start that while the other one is running, and also and then jumping over from that task to another one. And doing this, you can avoid blocking or freezing your app. Let's say that you start an intensive task such as downloading an image. While that's happening, your app is standing idle, so it's not really doing anything. So in that time, your app could be doing something else instead and be saving on time, but it's just stuck waiting for this task to finish before it's run. So that's why we would use asynchronous instead. So this is the synchronous flow. So this is what you might be a little more familiar with before learning asynchronous. Let's say we have 4 tasks we want to do. First, we need to download an image. Then we need to get data from API number 1, and then we have to get data from API number 2. And finally, we render our content in our app. So using the synchronous workflow, we would have to wait for one task to completely finish until we can start the next one. And you can see here that it takes a long time. Even though for apps, it might not take up to 45 seconds, it's usually more of a matter of milliseconds. The fact of the matter is that we can't go from downloading an image, or we can't do getting data from API 1 until we have fully downloaded the image, even though this is being done in another area, not in the app, and we could have been doing something in that time instead. So we are completely blocked, our app is completely frozen, and we are wasting a lot of time. But instead, if we did the asynchronous workflow, it would look a little more something like this. So we have the same 4 tasks. We are downloading an image, getting the data from APIs 1 and 2, and then we're rendering the content. But using asynchronous workflow, we can first just start the process of downloading the image, and then we can hop over to getting the data from the API 1 while it's downloading, and then start that process, and then jump over to API 2, start that process, and then finally jump to render content. So all this stuff is being run at the same time, and there's not necessarily an order that you have to follow sequentially. So the total time taken by these tasks is almost more than half as fast. So you can definitely see the benefits of asynchronous programming. So we learned last week that one way to work with asynchronous code in JavaScript is using the async await syntax. And using async await, you can write asynchronous code using something that looks a lot like synchronous or sequential looking code. And by this, I mean that you avoid digging your code into deeper and deeper curly braces as your code just keeps going to the right and it's harder to manage. Everything is stayed at the top level and it's easier to read. And you might recall that asynchronous, an async await, I should say, is a way to work with promises. And promises in JavaScript are an object that wrap around asynchronous code. And what promises allow us to do is say that we don't know when the stuff inside the promise is going to be done, but once it's done, we are able to extract a value out of it and do something with that value. Okay, so let's go into the syntax specifically. So you might remember that you have to add async to whatever function is holding your asynchronous code for async await to work. So here you can see that we've highlighted the async keyword, which we have added before our arrow function. Okay, so asynchronous functions are what we're trying to work with. And the way that we use these asynchronous functions is that they would return a promise. And by itself, we can't really do much with this promise. We have to extract the value out of it in some way. And using async await, we would use the await keyword and put that in front of whatever asynchronous function is returning this promise. And with that, we can then extract the actual value out of this promise once it's done running, and then store it into a JavaScript variable, which we can then use as we would any other JavaScript variable. Okay, so that was async await. Are there any questions related to that? Okay, if not, let's hop into another thing we learned last week, which was use effect. And use effect is a React hook that lets us perform side effects. And by what I mean by side effects is anything in your code that does some computation or performs changes on any variables, constants, or functions that are outside of the function itself and what the function would normally be able to access. So some examples of this are fetching data asynchronously from another area on the internet, which is what we're probably going to be familiar with today, and also updating UI with the state and watching over some variable and running some function whenever it changes. So using useEffect, we have 2 parameters. The second one's optional, but the first one's required. The first one is the function, otherwise known as the effect that we want useEffect to run. And inside of this function, we have some computation that performs the side effect. So the second parameter I mentioned is optional, and you can store an array of variables that you want to watch over. And whenever one of these variables change, the function will run again. So one benefit of useEffect is that you can have it run consistently, no matter how many times your component gets rendered behind the scenes. So because of that, we can run some logic that only gets run right when the component comes to life. And how we do that using useEffect syntax is using an empty array. So this tells JavaScript and React that you only want this function to be run once, right at the beginning of the component's life. Okay, so now let's get into something a little bit more new. So up to this point, we've sort of just assumed that our asynchronous code using async await will be completely fine. There won't be any errors. But that is an ideal world, and unfortunately, there are errors that can pop up anytime, and we want a way to handle them. And with async await, the typical way to handle that is using what is known as the try-catch block. And it's called the try-catch block because there's two parts to it. There is the try block, which will contain all of the normal case code. So this is what used to be outside without the try-catch block and what you want to run normally if there aren't any errors. So here you can see that there's a value we await out of some asynchronous task, and then we're just going to log the value. So that would be run normally. However, if somewhere in the process something went completely and terribly wrong, we want a way to handle it. And once that error occurs, we will gracefully jump into the catch block. And the catch block handles anything that, this is the code that you would run in the error case. So it would have some way of handling the error gracefully. Also note here that catch has an extra parameter, which you can name anything, but I've just chosen the name error here. And once you have that parameter, that contains info about the error that you received. So you can log it for some information, or maybe if you are looking for some specific error, you can do some specific code to handle that. Cool. Are there any questions before we hop into the poll? Okay, let's do a quick recap poll. This will just be all the recap information plus the try catch. Poop. Stop the poll right there. And poll, share results. Okay. Number 1, which of the following is false about async await? Yeah, cool. Looks like a majority of you got it right. The async keyword should go in front of the promise is false. We want the await keyword to go in front of the promise to take out its value. Number 2, how would I create a use effect that is only run once in the beginning of the component's life? Cool. Again, the majority of you did a great job. The key part that we're looking for is the second parameter should be an empty array to tell React that we want it to only be run at the beginning. Okay, number 3, what do we want? What do we surround our code in to be able to handle errors for async await? And yes, it is try catch. Cool, great job, everyone. Let me stop sharing. And let's hop back in to the new stuff. So let's talk about local storage. So why exactly would I use something like local storage before I even give you the definition? So let's say we have these two functional components here. The first one, we have a state ball that we have set the initial state to be up. And then we have the second functional component, and the second one is trying to look for ball and check its value. And if it has a specific value, then we wanted to log I'm spiking the ball. But you can kind of see already that there's an error with this, this logic, because the ball in the second component is trying to access something that doesn't exist within the component. So it's going to give an error because it in fact exists in the first component. So how exactly will we get around this? So one solution might be to put the second component into the first one and pass down the ball value as a prop. Or as we saw before, or we just learned in the first half, this could also have been passing down the data as a navigation parameter if we're trying to navigate to the screen. So for both of these, there is still something that isn't too cool. What if our ball, instead of just being a normal string, was a really big JavaScript object? I mean, here I've only shown 2 properties and values, but we can imagine that it has a bunch more data. And Christy kind of mentioned this earlier, but this is a lot of data, and especially if you're working with navigation params, it's going to be duplicated over. And not to mention, like I said before, this has to have some sort of parent-child relationship between the first and second component, the parent being the component that contains the other component. So that isn't really flexible, especially if these two components are concerning two completely separate things. So ideally, we would have some sort of data storage mechanism that is separate from these two. So instead of having ball inside the components, it would be this outside area that both of these components would look for the value of ball. And in other words, we want this value to be globally accessible, which means we want it to be able to access it across the app, no matter where we are. So that is reason number one for why we would use local storage. Let's get into reason number two. So let's say that I have created this fan site that hypothetically I may or may not have in real life, and I have some data associated with it. So I have an image, I have a couple of, I have the title, I have the description, and maybe some other details I want to add on later on. So this is successfully running, and it's being run on my Expo server that I've started up. But let's say that all this data I have stored inside my app itself, and I have added it after the app was run. But what if something really bad happens and either our app crashes or our Expo server dies? At any point in this pipeline, if something goes down and later on it comes back up, we will actually have lost all of this data because we didn't store it in a separate place and it was all in our app and it's now gone, which is not good. Ideally, we want our data to stick around, even though there's some emergency thing that happens. And in other words, we want our data to persist. So in order to do that, we also, again, need to have a separate storage mechanism that is separate from our app and from our Expo server that contains all this data. So once either our app crashes or our Expo server goes down, we'll be completely fine. All our data will still be there, and we'll still have this pretty cool fan site. So now that I've given you the motivation, we can jump into what local storage exactly is. So local storage is a storage mechanism, as the name suggests, to be able to store persistent data globally across your app. So that means that no matter where you are in your app, you have access to all this data and it will persist. So even though something very terrible happens to your app or your server, it will still all be available to you. One thing to note is that local storage is a singular source of data. So you avoid the duplication problem that we had before, and we avoid having redundant data. So in React Native, there are two implementations of local storage that I'll get into today. One is async storage, and the other is secure store. Okay, so let's go into async storage first. So as the name suggests, async storage is asynchronous. So that means that if you're adding data or you're getting data, all this stuff will be done through an asynchronous interface. It is a key value storage system. So you might be more familiar with the concept of keys and values in JavaScript objects. So the way you access a particular value inside an object is through a key. So using this logic, we've developed async storage, which is a key value storage system. So you use a key, which you might have known as a property before, to obtain the value associated with the key. So whenever we add new stuff into the storage, we are providing both the key and the value associated to it. Okay, so we of course need with our storage to be able to add data. So how we do that using async storage is using the set item method. And the way set item method works is that it has two parameters. The first one is the key, and it has to be a string. And the second parameter is a value, and it is those two that are associated with each other and added to our storage. So here I just have a try catch block. This all stuff is just standard that we should be doing for good practice. But the line that we should be paying attention to is this one. Because it's asynchronous, we have to, of course, await it. And you can imagine that we are in an async function. I just left it out for simplicity. And then we call async storage.setItem. And then we want to put the key in, which is ball, which is a string. And then we want to associate that key with up, which is its value. Okay, so let's just walk through that line in more detail. So we put await async storage.setItem. ball up, and once this is run, our async storage will now contain the key and the value, and we are able to get it out at any point, and it'll persist. So now let's take a look at how you would get it out once you've put in this data. So to fetch data in async storage, you use getItem, which fetches a value from storage by its key. So getItem only requires one parameter, which is the key that you're looking for, which again has to be a string. And once you await that out and you find the key that you're looking for, and you await it, it'll extract the value associated with that key out, and you can store it into a variable. And then after that, you can use the variable as you would any other JavaScript variable. So let's walk through that again. Sorry, that should say getItem at the top. But let's walk through the line that says async storage.getItem and stores it into a value. Once this is run, because we've already stored ball and up into the storage, this will be good. We're all good. And we'll have the value, and it'll be stored in a variable. But let's say that we don't have, we have a key that we haven't added into the storage yet, which you can see here. And you can see the current state of the storage. What exactly happens in this case? Will our storage just completely explode and we won't be able to have any way of handling it? Well, using async storage is not that bad. So if you have a key that does not exist in your storage, what will actually return out of this call to await async storage.getItem is null. So as long as you have some way of handling that case where the key doesn't exist, in this case, I have this if statement that checks if value isn't null and then doing something to that value, you should be good to go. Okay, so I've only gone over setItem and getItem, which are the two most important, but there are other methods associated with async storage that they provide. I'll just bring attention to a couple of them. Async storage.removeItem will remove a key and its value out, and you just provide the key. Multi-get and multi-set are pretty similar to setItem and getItem, but they take in arrays of keys and arrays of values so that you can do multiple sets or gets at one time. And if you're curious to exactly what these do, I've put a link in the slides to the official documentation for async storage. Cool. Okay, so if you want to use async storage in your project, you of course have to first install the JavaScript library and then import it into your project. So to install it, you use npm install React Native async storage / async storage, and then to import it into whatever file you want, you would just import async storage from there. Okay, so let me hop into the demo, but before that, are there any questions I can answer? What's the purpose of the at in front of the name? I'm honestly not too sure. That is just the naming they went with the library itself. Um, it might be a convention because I've definitely seen it before, but I'm not too sure about that one. If any of the mentors know more about that, then you can hop on that. Okay. Let me hop over into the demo. So how is the font size before I start?
You make it a bit bigger.
Yeah. Is that better?
Yeah, that's good.
Okay, cool. So over here, I've already have the app up and running. This is almost exactly where we've left off on Christie's section. So we have our to-dos that she's added as well. You can click them if you're done and they'll activate. And if you click into one of them, it'll give you more information about it. So that is all good. As a reminder, this screen that you're looking at is the list screen. So we have the initial to-dos that we have here, and that's what you see over here. And we have a flat list that displays all our to-do lists. And we have a go to details function that we pass into our list item over here as a param because it's navigation. And once it has that information, then it can display it in this expanded section. Cool. So the first thing that we're going to tackle is that issue we had in the first section, that we want to only be able to pass the ID into the screen, but we have no real way of doing that if they don't pass it explicitly. Well, now with async storage, we have the solution. All we have to do before we navigate to this page is set the info for the item in async storage, and then we'll hop over to the other screen, which is the list item screen. And then from there, we will fetch the key that we're looking for that. So the area that we want to update is the go to details section. So once we click on this expanded section, we want to, instead of just jumping right into the navigation, first you want to set the item in async storage. So let's go ahead and update that really quick. So of course, to use async storage, I've already installed it. So all I have to do is import async storage from React Native async storage. Cool, as autocomplete. There's no way I would have remembered that. Okay, so once we have access to that, we can first set the item. And again, because now we're working with asynchronous code, we have to slightly update this function that gets passed into an async function. So let's add async into that definition. And once we've done that, let us set our item, which if you remember is await async storage dot set item. So if we want to be able to access this by its ID, then the ID has to be the key. And let's do index, which is provided to us by flatlist and is a unique identifier for all of our different to-do items. So let's make that the key. To index, and remember that the key has to be a string. So let's use JavaScript's built-in method for numbers, which is toString. And let's do the value, which is item. And then once we do that, we can instead just pass in one single key and value into our param, which will be ID, and we'll set that to index. So at this stage, if I save and run, we will actually get an error. And that's because item, as it is here, is a normal JavaScript object. And one thing about async storage is that it requires everything to be a string. So one way to get around this is using JSON, which we talked about a little bit last week, but as a refresher, it stands for JavaScript object notation, and it looks really similar to an object, except it is a string representation of it. So with that, we are able to store our JavaScript objects into async storage. And the way to convert JavaScript objects into JSON is using this pretty nifty built-in function, again in JavaScript, which is json.stringify. And as a parameter, we'll pass in this item object. And that will successfully convert it to JSON. Okay. So if I hit save, any ugly errors? No, you're good. Perfect. Okay, so this is cool. We've now passed the ID into the list items screen, so let's hop over there. But because we're now only passing the ID, all of this stuff that we're looking for in the parameters is now irrelevant, and we only have ID. So let's update that really quick. The only thing we should be getting out of our object destructuring is ID. And now that we have ID, let's do the fetching process. So we'll now, in this screen, get the item that we just set. So since this is done asynchronously, it is, in fact, a side effect. So because we're fetching data, we want to put this in a use effect. So right at the start, we want this to be fetched. So because it's right at the start, we want the second parameter to be an empty array. So let me go ahead and add that, use effect. Let me get rid of this second parameter first, so that'll be an empty array. And in this first section, we want to have a function. Okay. So in this function, we want to await out the item, and then we want to have that item available outside of this use effect. So what I'm going to do is I'm going to add state into this. So once we have the ID, I'm going to, let me add use state first before I go on that track. So I want to have the item in a different way now. So what I'll do is have an item as our state. So item set item equals use state. And we'll just set it as an empty object initially. So now in our use effect, what I want to do is first fetch out this item and then set our state to be that. And let me go ahead and update this bottom part too. We no longer have access to title, done, and details. These will instead now be properties of our item state. So that will be item.title, item.done, and item.details. Okay. With that all out of the way, let us now tackle the fetching. So let's just call this function that I haven't defined yet, which is fetch to do. And then above that use effect, let us define that function. So let's do const fetch to do. It is going to be working with asynchronous code, so we can just already add async to that. And then because we should be good programmers, let's add our try catch block. So the catch will just take in a parameter. I'm going to use E just to make it a little bit easier for myself. And then we'll just console log that out. So now in our try, we want to get the item. So that will be const value equals await async storage dot get item. And we want to get the ID. So we passed it down as a parameter in our navigation. So now all we have to do is find that. So we'll just do ID to string. And then after we do that, we will set our new state. So set item into value. Okay, so this might look like it works, but remember that we converted our value into JSON. And while this is a good way to store data into our storage, we can't work with it as an object in JavaScript. So what I'm going to use is another built-in function called json.parse, which does the opposite of what stringify does, and it takes a JSON and makes it into a JavaScript object. So let me just surround all my code with that, json.parse. So this will extract the value out, the await will, and once we have that value, which is JSON, we will parse it out and turn it into a normal JavaScript object. So now we are good to go. Okay, so this part of the demo isn't as cool because if everything goes well, literally nothing should have changed. So let me see, let me hard refresh. So once I click this, we'll see that, great, yeah. So it's working exactly as intended. Once you expand, you'll get more information about the to-do item. And if right now it's done, if I uncheck that and click it again, it'll say not done yet. So we can see that it's doing this whole process of setting async storage, jumping into the screen, and then getting that item and setting the item to that pretty seamlessly, which is all good. Cool. Any other questions? Okay. Let us now tackle the harder part, which is hooking up the new item screen so we can create new to-do items. So that is all in new item screen.js here. Let me also show you what it actually looks like in the app. Once I click new item, it'll navigate over to the screen. And this is what you're seeing on both the left and right. It has two text inputs, one for the title and one for the details. And in our code, we have state for that. So whatever we write in there will become our values for title and details. And we also have this create button on the bottom. If I scroll down to where that is in the code, line 33, that will be button, and it has a title called create. But right now, our button's pretty useless. It doesn't have any on-press property that does anything. So if we just click create, nothing happens. So what we want to happen is that once we click create, we want it to first navigate back to the home screen. And while that's being done, we want it to update the storage so that it contains the new item to show. that we've just created too. So let's do that. Let's add an onPress that does that. So onPress equals let me just put a function that I haven't declared yet, but I will call add to do. So let us define that up in the top now. I'll put it over here. So what this function will do is, let's see. So what it'll do, because we first have the titles and details, but our data really isn't using that. What it actually is looking for is an item object that contains the title, details, and done property. Let's first create a new to-do that follows that format a little bit more. So we're going to call that new object, new to-do. And as its properties, we are going to have a title, and this will equal to the state title. Let's have a details, which again will be the state. And let's do done, which will just be false, because when you create a new to-do, there's no physical way you could have done it in an instant, unless you're really good, I guess. And then after we have that new object, let us navigate back. So navigation dot navigate, and we will do a to-do list. Since our home screen was named that, I believe. And then as our data, we'll send this new to-do down. Okay, so after this has been added, we will have navigated back into the to-do list screen, which is list screen. We'll just jump back in there. So now that we're back into the list screen, we want to be able to have some sort of way to handle this new object that has been created. But how exactly are we able to let this home screen know that a new item has been added? Well, we're trying to watch over a variable. So I'm hoping cylinders are firing in your head, because this is the use of another use effect. And we'll be looking for this variable. And whenever it changes, we want the use effect to run its function again. Okay, so let's add a use effect for that. So use effect. We'll just do an empty function for now. And as its second parameter, we are going to be looking for this to-do object that we've just passed down. So that'll be in route.params.to-do. And let's use what we just learned in the first section, which was the question mark dot operator, because we're not sure if this params object exists. And if it doesn't exist, it will be undefined in JavaScript. And the last thing that we want to do is access a non-existent to-do property in a non-existent object, and your JavaScript code will explode. Well, not really, there's just going to be an error. But this is a safer way to handle it. So it'll just say that if params doesn't exist, then we'll just stop there and pass undefined. But if it does exist, we will then know it's safe enough to access to-do, and then we'll access to-do like so. So we're watching over that variable, and assuming it's changed, it will run this function. And let's be safe again. So let's make sure that this exists. If route.params.do exists, then we'll run some code. Otherwise, we won't do anything. And let's just make another function here. We'll call it add to do, just for simplicity. And oh, that's not what I want. Add to do. Okay, add to do, and we'll pass in route.params.to-do. And notice here that I'm not going to add the question mark dot operator here, because once we know for sure in this if check that it exists, we're able to safely use it as we would any other object inside. Okay, so now we're calling this non-existent add to do function. Let us make it exist. So let's have a const add to do. It'll be async, since we're going to be working with async storage. And as a parameter, let's call it a new to do because that's what we're passing around. Okay. Again, let's just get the try catch block out of the way. It'll have an E parameter and it'll just console that out. Okay, so in our try block, we have this new to do object that we've been passing through. And we have, if you remember, the state to-dos that keeps track of all the to-dos. So what we want to do is add this new to-do at the end of this list so that because it's state, React will know that it needs to be rendered so that it can show this new item. So let's go. Let's use the brain cells that we've gained through this workshop, and let's use the spread operator. So we have this new object that will contain our new to do, and how we can do this and how we can define an array that contains both the old data and the new object is by using the spread operator like this. So we'll do ... to do's, and then we will add the new to do object at the end. So this is just a nice way of condensing all that code that you used to have to do in order to push a new value into this array. Once we have that new to do list, we will then update our new to dos. So our to do state, sorry. So let's set to dos, and then we will set it to this new array. Okay, let me save this. And let's try to add an item. So let's say I want to learn how to receive, and then details. Receiving is very hard. And once I hit create, hopefully it will jump back. Cool. Okay, so it'll jump back to the to-do list home screen. And now you can see our new object here, which is great. We can keep adding stuff. Let's just say like, what else is volleyball related? Buy a volleyball. I am poor. Let's create that. Okay, so we not only are able to add one item, we're able to add multiple items. But let's say disaster strikes and our app crashes and our server dies. The way I'll simulate that is just exiting out of the app, but you can imagine it'll be much more violent than that. So if I open up the app again, and I go back into this app, wait for it to build. Oh no, all our items are gone. And you might already be noticing why, but this is how the app would have been without storage, because we're not looking for the data inside the storage. So this is behaving as it would without async storage at all. That's not good. We want that data to persist even though our app dies. So let's go ahead and update this so that it doesn't die. What we'll do now is we'll set the value of a to-dos key, and we just called it to-dos arbitrarily, but you can call whatever you want. And then let's see, async storage.set item. So let's set the value of the key to-dos. And again, because this is an object and we want to change it to a string representation first, we use json.stringify new to-dos. So now our storage contains the newly updated value of all our to-dos. Sweet, okay. Let's see. Okay, so even though we've set the item in our list screen, we have not yet created the way to get the item once the app comes to existence. So this will behave the same way as you just saw. If your app dies, then you'll lose all the data that you so hard, painstakingly added on. So what we want is when this screen comes into existence, we want to first look at our local storage to see if there's any data inside there. And if there is, we will fetch it from there and we'll update our to-do state to contain that data. So let's go ahead and do that. And of course, you might have already figured it out, but because we wanted this to run at the beginning, we will add another use effect. So what this use effect will do is run at the beginning, so it'll be an empty array, and we'll just have it call this non-existent function called fetch existing to-dos. And we'll define that down here. What fetch existing to-dos will do is it'll be an async function. And it'll retrieve the to-dos key from the storage. So let's store it in a variable called existing to-dos. We will await async storage dot get item, and we're looking for the key to-dos. And once we have that, we'll store it into existing to-dos. Again, because it is JSON, we want it to become converted into a JavaScript object first. So we'll do that with json.parse. And now we're good to go. Let's say if existing to-dos exists, because remember, if this value has never been set before, it'll be null. So let's make sure that we're working with some data. Once we've confirmed that, we'll set our to-dos to that value, which should be the current state of our to-do list. And I almost forgot, but let's add a try catch. Console.log. Let's copy over all this code. Let's paste it in. Okay. So now I think the entire workflow is done. So if I save this, cool. Now, if I save and refresh, you can see all that data that I stored previously, but had no way of getting out, now exists. So we can see that it does persist, which is great. So let's do the same thing again if my app dies. And I open it up again. Pause for suspense. Oh, I just forgot to click. Okay, yes. Max, you don't know how afraid I was about that, but it is there. So we know that this entire workflow works. Async storage is doing its job. We're able to access it globally, which is what we did between the list screen and the list item screen when we expanded out. And we'll do that here for our other stuff. And we've just seen that it also persists. This is great. Cool, so that's all I have for my demo for async storage. Before we hop into secure store, let me open up a poll. And there we go. Stop it there. Okay, let me share results. Number 1, how can I extract the value for an item with key, city, and async storage? Nice. Looks like all of you got it right. Yes, that is the syntax. We'll get item, and we will have one parameter, which is the key, which is city. Okay, number 2, how can I add a new entry in async storage with key fruit and value banana? This is a tricky one, but the correct answer is the second one. Or I mean, let me just say it out. Await async storage dot set item and 2 separate parameters with string fruit, comma, banana. Not a single object that is property fruit and value banana. A little tricky, but yeah. Number 3, what is wrong with the following code? Const value, name Eugene, age is 20, and we set the item and info with info and value. Cool, it looks like all of you got it right. Thank God you guys didn't put the first one, but yes, the value is not in JSON. So it will actually, I tested this out, it'll crash the app if you don't set it to JSON first. So be sure to do that. Okay. Nice, let us hop back in. Let's look at secure store. So now we know all about async storage, but one thing to note about async storage is that it adds key value pairs in plain text. And what plain text is and what it means is that literally humans can just read it right away. So right here we have an example of it. We just have height, age, and name. and we see the exact values that they correspond to. So this is great for most intents and purposes, but the fact is that it can be viewed by anyone. So if you have some more sensitive information, like password, this is bad. Anyone can see it, and the people who can see it are not always the best and nicest people. So ideally, we want to make sure that these fields are unreadable to humans. So maybe we have this way to make it look like a bunch of garbage letters and numbers, which we call encrypting. And the only way to be able to know what they are is if you're authorized to be able to know what they are, and you can decrypt it. So we also want to make sure that only people who are allowed to access it will access it. So here we have 3 separate Expo projects belonging to 3 separate people. And only the people who the Expo project belongs to are able to decrypt it and find what the actual info means. But you are not able to see what other Expo projects have as their data. So for these reasons of added security, we look towards Secure Store as another option for storage, which is a way to first encrypt and then store key value pairs locally on your device. Since it's created by Expo, you have this added layer of security where each Expo project has a separate storage system, which can't be accessed by other Expo projects unless you explicitly invite them over to access it. Okay, so I'll go over this a little bit faster because the syntax is very similar to async store. Instead of set item to add data, it's set item async, which means you push a key and a value to its storage again. Again, it's looking for 2 parameters, which are its key and value. And again, because it's asynchronous, you await it. Okay, on the flip side, of course, you have fetching data. So instead of get item, it's get item async, and you fetch a value from a storage by its key, which is its only parameter. And like async storage, if the key does not exist, it will give you null. So you should have a way to gracefully handle that, like an if check to make sure it's not null. Okay, so here's some more methods besides set item async and get item async. Another one is delete item async, which was similar to what you saw before. It just gets rid of the value once you provided the key. And again, I've linked the documentation here if you're curious about all this stuff and you want to know about it more in detail. Okay, to use secure storage, again, you need to install it first and then import it into your project. So to install it, use expo install expo secure store. And to import it, you use import star as secure store from that location, which is expo secure store. Okay, let me just quickly demo secure store. This change will be really fast. All we have to do is swap out async storage with secure store. So let me import it. So import asterisk or star as secure store from expo secure store. I think is what it's called. Right? Yes. Okay. Okay, so once we have access to that, let's just straight up go into the areas that have async storage. Let's change this to secure store. And then this will be get item async instead of get item. So that's for fetching the to-dos once it comes, this component comes into existence. And then let's look for the set item, which is over here. Let's change that to secure store.setItem. We'll change it to async. And the rest of the stuff stays the same. So let's hit save. Let me make sure that async store doesn't exist anywhere. Ah, I figured it. Okay, so here we also have to change async storage to secure store, and we'll change it to set item async. Okay, so now the only existence is in the actual import line. Okay, we're good to go. So if I hit save, let's reload. Well, let's add a new item. This will just be learn how to receive. Receiving is hard. Okay, and once we do that, we have our new item there. And if I do the thing again, where I close the app and refresh, we'll see that our data is still there. Cool. So that's all I have for the Secure Store demo, because they're pretty similar. So let's do a poll. I will not spend too much time on this one. I can see that we're running short on time, but I just wanted to give you guys a chance to see the questions. Let me share results. Okay, what is the biggest difference between async storage and secure store? Yep, all of you got it right. Secure store is encrypted. Async storage does it in plain text. Number 2, how would I get an item with key color in secure store? Cool, yep, so that will be secure store.get item async and the key. Number 3, how can I set an item with key brand and value Apple using secure store? And yes, looks like all of you got it right. I wait, secure store.set item async brand Apple. Awesome, okay. So the last thing I will leave you with is a discussion on async storage versus secure store. The fact of the matter is that both are really similar and both are really easy to use. The biggest difference, of course, if you don't see yourself using async storage, if you don't see yourself using a lot of sensitive information, then async storage is perfectly fine. But if you need an extra layer of security, then secure store is your way to go. So besides async storage and secure store, there are other options when it comes to storage. One of them is SQLite. So if you're familiar with working with tabular databases with SQL, and that's your jam, then maybe that's the way to go. But if you're looking for a more persistent solution that exists outside of your app, that'll be Firebase, and which we'll be covering a lot more into detail next week. So stay tuned for that. But with that, thank you all for coming and sticking all the way through. Like I mentioned, next session will be Firebase with React Native. And also, please fill out our feedback form again. You get a chance to win an Amazon gift card, so that's always cool. And we do take your feedback with a lot of consideration, and we use it to improve our workshops. But yeah, thank you guys so much for staying. It's a pleasure.